Hey Virgil! Your portal opening days are over. Give me the Yamato. If you want it, you'll have to take it. I had a feeling you'd say that. Devil May Cry has always been known for having its voice saucing it up on style points. I mean, style is literally the gameplay. Every time you finish off an enemy, a super saucy, stylish finisher animation plays. So how did they make it look so good? While I was investigating DMC's sister franchise, Resident Evil, for our last video, I stumbled on an insanely cool and awesome treasure. The cheat code behind DMC 5's smokin' sexy style. You may be wondering, what exactly is VAT? Well, fear not, because I'm about to be the one to fill your dark soul with light! And by that, I mean the light of nerdy knowledge. Essentially, VAT is a super cool technique for animating things, especially fluids, cloths, particles, and deformation. All you need to understand VAT, though, is to have at some point in your life experienced a grade 6 math class and to know your ABCs. A, B, C, D, E. This party's getting crazy. Let's rock. First, starting with V. No, not that V! The V in VAT stands for vertex. Now, you may be wondering what the vertex of vertex is, and luckily for all of us, elementary school math has the answer. Hey kids, know what a vertex is? A vertex is the most important point on a shape. It's the point where lines meet. In geometry, we use vertices to literally define shapes. A triangle, for example, is a shape made by connecting 3 vertices. In games and computer graphics, vertices do even more than that. Each vertex stores important information about itself, like its position, XYZ in the game world, its color, RGB, at that position, its normal, directional arrow, showing where it's facing. Of course, vertices in computer graphics are still most famous for making triangles. Take a look at this great image from Wikipedia. Vertices are connected through edges to create triangles, to create polygons that create the end result of what we see, a box. Now, when we connect a bunch of polygons together, we call the end result the fancy game design term of mesh. In the above image, the box is a mesh. This is also a mesh. In a nutshell, vertices are points you connect to make shapes. In games, they also store important information like position, XYZ, and color, RGB. Meshes are objects made by connecting a bunch of shapes. So far, so good? Next, we'll move on to the A in VAT. Traditionally, in animation, a mesh is bound to a skeleton. Let's pretend this is our skeleton. The skeleton of an object is what moves around. Usually it's just a bunch of lines, as bare bones as can be. Let's pretend this is our mesh. The mesh should actually cover the entirety of the skeleton, but for demonstration's sake, let's focus only here. And let this be a vertex. When we move the skeleton, the mesh will deform to the movement, and the vertices of the mesh will move accordingly. This is because every single one of the mesh's vertices are attached to the skeleton's bones. The skeleton's movements are all calculated by your computer or console's CPU at runtime. Then, the vertices are transformed accordingly by the GPU. A CPU is really good at calculating math. A GPU is really good at working with visual data. However, for squishy monster blood bubbles flying through the air, just makes no sense for these squelchers to have bones or skeletons. They just... This is why VAT uses no bones or skeletons. So what the heck does it use to make these super movement-y animations? The final piece of the VAT puzzle is T, which stands for texture. A texture in video games is exactly as it sounds. It's a 2D image that you drape over a 3D object, almost like it's a cloth or gift wrap or wallpaper. Here's another great image from Wikipedia. You got the mesh in the top left and the texture in the bottom left. Watch how we apply the texture to the mesh. So, a texture is a static image made up of RGB values. We slap it onto objects to give them color. But what if I told you that DMC5 actually uses textures to create movement? That's right, this wallpaper-like thing can be used for animation? Well, this is where the magic is. Let's go back to the V and A in VAT. Remember, one of the things that a vertex stores is position data, X, Y, Z. When an object is animated, its vertices move and its position changes. Position is X, Y, Z. 3 values. You know what else has 3 values? RGB, color. That's right, everyone. We're using RGB color to represent XYZ movement. Let me explain. Instead of using a texture for what we'd usually use it for, i.e. giving color to an object in the game, we can use it as a secret code tapestry to tell us where to move vertices. And those XYZ to RGB textures, they look like this. 1 pixel in the texture stores position data for a single vertex. This pixel is pink, let's say. RGB value of 25143.171. Your game engine reads this RGB and translates it to a position value XYZ. So now we know where the vertex is. Now, 1 row in this texture represents 1 frame of animation. This row number 5, for example, contains information about every single vertex's whereabouts for the 5th frame. To play the animation, we just go through each row to display each frame. But wait, it gets even better. Because a VAT has every frame's data readily available, I can just say, I want to know what this animation looks like at the 15-second mark. Then we just find that row, read it, and display it. Pretty simple, right? One more thing. Remember, vertices don't only store position information. They store way more about themselves, like the normal, where it's facing. So we just make another texture storing its normal information, and so on and so forth. So, the incredibly sneaky genius cheat code behind DMC's animations is just a static image. In summary, whereas traditionally you would use a skeleton to create movement with your CPU, then find your vertices to each bone using your GPU, with VAT, you can just look up what each vertex looks like at a given timestamp to recreate it. Isn't that genius? The texture that you made has all the information you need, and the GPU can skip any CPU processing altogether. But where its efficiency really shines is in DMC's cinematic slow-mos during finishers. Because the GPU is just looking up where everything goes, you rarely get jittering or skipped frames because the CPU is trying to process everything. I guess you could say that with VAT, DMC5 really hit the jackpot. As always, I've linked my references and research links in the description for the keeners out there to read. If there's a game you want me to investigate next, leave a comment.